Hello everyone. Today we are in the chapter 3 of 8086, which is organized of IBM personal computers. Intel 8086 family microprocessors have some histories. By these differential diagrams you can easily understand about their histories. Here is the diagram or the chart of difference between 8086 and 8088. The major difference are 8086 is 6 byte long and this one is 4. These have two banks. Even is for lower banks and odd is for higher banks, but 8088 doesn't have any bank. It have 16-bit data bus. This one only 8. This can be multiplexed, but this cannot. There are 3 clock speed 5, 8 and 10 in 8086, but in 88 we have only 5 and 8. You can have a snap of this one. Again, there are difference between some microprocessor is given here. In this last section 80286, this difference is important for your small questions in your examination. You can have a snap of this one. 80286 microprocessor. It have two modes of operation and more address memory. It has virtual memory in process mode. Those are not very much important for your examination because 8086 is much more important than them, and 8086 is very much widely used and discussed in the BSc sections. Now, registers. Registers are information inside a microprocessor is stored in register. The registers are classified according to functions of their performs. In general, data register holds the data and address registers hold the addresses. So that's how the register works. First of all, we have the data registers. The data registers we have already seen in the EU section of 8086. Here, the higher bytes of AX is called the AH and the lower byte is called the AL section. Here, the registers can be classified by AX is for the accumulator section, BX is for the base, C is for the count, and D is for the data. And now here stack pointer is denoted by the SP, BP the base pointer, SI is the source index, DI is the destination index, and lastly IP is the instruction pointer, which is very important in segment registers. Here we have the segments. Here CS is for the code segment, DS is for the data segment, SS is the stack segment, and ES is the extra segment. Those segments are situated in the BIU section and registers are on the EU section. In here, for the accumulator registers is for the arithmetical and transfer sections. If you done arithmetical task and transform data, that means the accumulator register will work. Base register is for the address registers. That's why this is used in translate and it is called the XLAT. Now the count register is for the loop construction. If you run a loop in your program, then the counting is divided and counted by the counter register, which is denoted as CX. Data register. It is used in multiplication and division, and also in I operation uses the data registers. In segment section, we have firstly the code segment, which is used for addressing the memory location. The memory location are addressed by the code segments. As the CS registers is automatically updated doing far jump and far call and far return instruction. That means if you condition an unconditional jump in your program or recursive call in your program, then the code segment will work. In the stack segment section, the SS register can be changed directly using the pop instruction. The data segment is for the program data to be stored. Here it can directly pop or LDS the instructions. Now the extra segment. Extra segment is also for the program data storage sections. Here it can perform pop and LES instructions. Those segments are very important for your exam point of view. Please read them carefully. Now we are in the pointer section. Here first we have the stack pointer. Stack pointer is to point on the stack. It means it stores the base address of the stack segment. So stack pointer and stack segment, which is denoted as SS, is connected with each other. Here BP is denoted as base pointer. Here register is primarily used to access the data on the stack. Here SI and DI are for source and destination index. Those are the memory location data segments which can easily conclusive by the memory location. This SI is for the source index and this one DI is for the destination index to search the access memory location easily. Now we are in the memory section. This memory can be go up to 24 kilobytes because 2 to the power 16 is 24 kilobytes. Now we will discuss about segment and offsets. Segment. A memory location may be specified by providing a segment number and an offset written in a form of segment. Offset is known as a logical address. For example, we have A4FB 4872H. It means offset here is 4872 hexadecimal within the segment volume A4FB hexadecimal. To be obtained, a 20-bit physical address by logical addresses. How we will discover this physical address by A4FB 4872. Here you can see that the A4FB, then lastly we added a 0 because we are transforming a 16-bit to a 20-bit physical address. This one is a 16-bit address and this one is also a 16-bit address. Now we will generate a 20-bit physical address. That's the reason we added a extra 0 and added 4872 with that. That is how we get A98226, which is the 20-bit physical address. That's how we generated 20-bit physical address by segment and offset addresses. Here are the math of location and segments. Those maths are very easy. You can try them at your home. This question is very important, that is why we are discussing it. A memory location have physical address 80FD2H. That means it is the 20-bit code. So that's why this is the physical address. In this segment it does have an offset which is BFD2. So now we need to generate the segment section. The formula is physical address equals to segment into 10 plus offset that we used in previous section. This is the segment number. We multiplied with 10, that is why we added a 0 in the last, and then lastly added the offset section. So this one is the basic formula. Physical address equals to segment into 10 plus offset. Now we need to generate the segment section. So segment into 10 equals to physical address minus offset. So here we minus physical offset, physical address and offset, and get the result 75000. And now we need only the segment section, so we divided it by 10, and lastly we get the segment address is 7500 hexadecimal. Now the instruction pointer. To access the instruction of 8086, we uses the registers which is CS and IP. CS is for code segment and IP is for instruction pointer. Instruction pointer points the next code is to be generated, and CS is to execute the code. Now the memory organization in PC. Here are some description of how the memory will organize in PC in the BIOS section. This is not very important for exam point of view, so we are skipping this. Here in the BIOS section you have a memory address. Those are reserved. Those are for your videos, application, and DOS section. Here are some port address and description. 20 and 21 is for the interrupt controller. Here 320 and 32 is for the hard disk section. You can have a snap of this diagram. Now the I/O port addresses. Here the startup operations. In 8086 or 8088 processor used to put in reset state. The C8, that means code section or segment register, is to set the FFF, which is the highest value, and IP is set to make it 0000, which is the lowest value. When the IP occurs, the section is empty and it results 0000, and after the code segment it becomes FFFF. So the first instruction to be executed located at FFFF0. The memory location is in the RAM and contain an instruction that transfer control to the starting point of the BIOS. The BIOS work on data area, and after the operating system is loaded to the memory, the command .com gives the control. This is the how to start up and operate. That easily means that if you start an operation, then firstly the BIOS works, then the control registers, and after it works, then it set the controls to the IP for set and reset functions. Those all are done by the operating system. That's for today. Thank you.